Perfectly fine, sir. Perfectly fine. We still have 7 to 8 minutes to go.
Yeah, once you say go, give the green signal, I will just start.
Yeah, sure, sir.
Yeah.
May I request to all the participants, kindly mute your microphone, please.
Welcome, ma'am.
With the permission of the speaker, shall we start the session, sir?
I'm okay.
Okay. Very good afternoon and welcome back to all the participants and respective speakers. Ladies and gentlemen, now I request and invite our next resource speaker, Shri Sudhanshu Nigam, for the presentation. Before he starts, let me introduce briefly about the speaker. Shri Sudhanshu Nigam started his career as drilling engineer with Mineral Exploration Corporation Limited under MOM after graduation. He worked at various capacities for 11 years. Then he left to join Atlas Corpo Pune as Indian head for geotechnical drilling and exploration for about 18 years. He has joined DSI underground for last 6 years and heading the Indian subcontinent operation. Sri Sudhanshu Nigam has been associated with many hydro projects in India and Bhutan, Nathapa, Jharki, Sardar Sarovar, Tehri, Tala, especially related to rock mass support. Mr. Sudhanshu is currently working with DSI Underground India Private Limited as a director for the Indian subcontinent region. Now I request Sri Sudhanshu Nigam to make the presentation, please. Over to you, sir.
Thank you. I think my presentation is visible to everybody.
Yes, sir.
Yes, sir.
Thank you. Good afternoon to everyone. As I have been introduced, so I'll go straight away to the presentation. I will be using mix of Hindi and English both because I'm more comfortable to Hindi because of traveling to the site mainly. Dividag or DSI is old company. It's more than 150 years old company. And the last change which has happened with the DSI is it has been acquired by Sandvik last year, rather last to last year. It happened on 25th of December 2020. So which is mentioned on the last line of the table. So now we will be a part of Sandvik company. In future, in coming months or days, you will hear that we will be offering under the Sandvik umbrella. Now, as far as the presence are concerned, we are present in almost all continents. More focus on Europe, Australia, and US market, especially mining as well as the tunneling, especially in Europe for Alps, etc., which is transport tunnels under construction. Now, if you see, if you're talking about the support system for tunnel, there are two kind of supports. One is the pre-support and the second is the post-support. Pre-support, we say that before the excavation, if we do the supporting of the rock mass, we call it pre-support, and post-support is after the excavation. If support system is inserted into the rock mass, then it is known as a post-support. So first we talk about the pre-support, how it is important and how it is being done. Now, pre-support has various options available, like pipe proofing or spiling, drainage system. Then we have the pipe umbrella system. There are different connections available. What are the new invention which has taken place in the pipe umbrella system? And there are automations available in pipe umbrella. How it can be done faster, because this is the slowest process in tunneling method. Whenever the pipe umbrella system is suggested, there is a reluctance from the execution that this will delay the excavation or the excavation cycle in total. So first of all, why we need the pre-support? If we look into this particular slide, you can see there is a rock mass which is falling from the face into the excavated tunnel. So when the rock mass is more poor or extremely poor, then it can form a chimney, which we have seen in many of the tunnel, or in the normal case, there will be a fall of rock mass into the excavated tunnel, but it will not form or connect it to the surface. So in both the cases, the pre-support is recommended, and how it has to be done or why it is being done, we will see in the next slide. Now, if suppose we see two situations, one is without the pre-support and second with pre-support. So what happens? There are stresses coming from the top and from the bottom, and the third one is from the face. So this will create that, okay, this is the space available where there is no stresses. So this material or rock mass will come into the excavated area. Whereas what we have done in pre-support, we have extended this stress zone slightly ahead of the excavated area. So all these stress zones are ahead of the excavated area. So nothing will happen to the excavation which has already taken place. So this is the advantage of the pipe umbrella system. Now, coming to the various options available, there are two options available which is used in the tunneling. One is the pipe roofing and the second is piling. So what is the difference between the piling or pipe roofing? There could be some different words being used by the tunneling or the experts at site. I'm not making any doubt on the different words being used, pipe roofing or the forepoling or spiling, but to just make a very common understanding between these two words, pipe roofing or forepoling. Forepoling, in our opinion, is common for all applications, where we call it whatever we do ahead of, or fore means ahead of that. So it's forepoling for all means. So there could be pipe roofing. Pipe roofing is where you use the pipe to make the roof more comfortable or safer. Whereas spiling is for the shorter length. When you do the spiling, that means it's for the smaller length of support which is provided on the rock mass for the roof protection. So where it is to be used and how it has to be used, now we can look into that. With pipe roofing, you can go for the longer drilling holes, say up to 9 to 24 meters. Whereas in case of spiling, it's only for the smaller length, 3 to 6 meter. This is depending upon the jumbo's drilling length, or 4 meter or 5 meter or 6 meter. If you can drive it, it's very good. Then with pipe roofing, you can go for the lower lookout angle, which is 6 to 8 degree. This is very much required. Otherwise, you will have more over breaks in the tunnel. So again, as a designer, it has to be considered that what could be the minimum lookout angle for pipe roofing. Whereas in case of spiling, the lookout angle is much higher. So you have more over break. But here, since the distance is lesser, 3 to 6 meters, so you can still manage. The diameter here can be from 76 to 168 mm of pipe roof. Normally we don't recommend the 76 because it's a very smaller one. But with spiling, the diameter starts from 51 to maximum 76, not more than that. You can go still smaller than this also. The overlaps between the two pipe roofs can be 50% overlapping. Here in this case, it's about 75% overlap. So you can see 75% it's basically overlapping, which needs more spiling to be done when the formation is weak. But where it has to be used, the pipe roofing has to be used where you have a longer stretch which has to be supported. Whereas in spiling, when a smaller zone has to be protected. So these are the major difference between these two. We'll have more clarity from this picture again. spiling, when you have a dry conditions, this can be still look into the an option. Good conditions means dry conditions, but weak to poor rock conditions. But when you have a flowing ground conditions, the pipe proofing has to be used because this gives a more free space available for water to seep out or escape through. So this is the best option when you have the flowing ground conditions in any of the tunnel. Now, just giving you more option available with the pipe proofing and spiling. With pipe proofing, you can start with 76 to 168, as I mentioned. Whereas in spiling, you can use the self-drilling anchors for spiling, or you can use the pipes of 50 mm dia also for the same applications. So this is how you can drive it. Either use the SDA, which can be driven through, or you can use the pipe, which can be inserted using the sacrificial bit into the desired length. Now, what could be the options or the best options available for pipe proofing? The first two options are against the spiling, whereas the last one is for the pipe proofing. We call it the AT system. Now, if you suppose we are drilling with the SDA system, then what happens? The diameter of the bit is much larger compared to the SDA or the anchor. Like if suppose you are drilling with the R32, the diameter of the anchor is 32 mm, whereas the bit used for drilling is 51 mm. So you can see this white space, which is basically removing the extra rock mass from the rock and then removing it as a cuttings. So there is a no good contact between the steel and the rock mass. So this is not a preferred conditions. Whereas in case of tube spile or pipe jacking or pipe insertion, we are almost drilling the same diameter. 51 mm is diameter of the bit and 50 mm is the diameter of the pipe which is being inserted. So it's almost close to the rock mass. Whereas in case of AT system or the pipe proofing, if suppose we are talking about 114.3 mm pipe umbrella, we are drilling up to 123 mm diameter of pipe, bit, and then inserting the 114.3 mm dia pipe. So we are still making a larger diameter of the hole and then inserting a smaller diameter of pipe. So these are the major difference between the two. So these two methods are more popular because they are more closer to the rock mass to support it, especially in the poor rock geological mass. We suggest that we should not disturb the rock mass, which is already in disturbed conditions. So that is the major criteria for selection of pipe proofing. So it has to be done considering the rock mass. Now, this is another options as a tube spile, we call it. This is now being used by IRCON very commonly in USBRL project. How it is being done? This is the pipe which is of 50 mm dia and the bit is 51 mm. So 50 mm dia pipe and 51 mm dia bit. This is attached to the jumbo, and then once once it is attached to the jumbo, this length of the casing pipe can be of different length, could be 3.5 to 4.5 meter length, and then using the bit, this is driven up to the desired depth. The advantage of the bit is, in case you still have the if you have the rock or the boulders into the ground, then this bit can be used for drilling through it and ensuring that the pipe is inserted to the desired depth. Otherwise, what happens sometimes in spiling, the desired length is not approached or reached by using the force of the jumbo. So this the bit ensures that the pipe is inserted into the rock mass up to the desired depth as per the design requirement. And then you make a complete perfect pipe umbrella system for the safety reasons. Now, in case of pipe umbrella system, what we have is we have the bit, the adapter, the casing pipe, which has the perforations, and then the end pipe with the last end as an injection plug, which is used for grouting. Now, the injection, the perforation also has the injection valves, which ensures that the cuttings does not go or penetrate through these holes into the casing pipe. So that, because when you start drilling with the pipe proofing system, the cuttings goes into the space between the drilling rod. These are the drilling rods or the extension rods and the casing pipes. So they pass through this, and because of the higher flow, they create a kind of a vacuum, and then the cuttings which is surrounded here, which is in poor rock geology, enter through these perforated holes which are open, and then create or take away the rock mass into the drilling fluid, which is normally the water, and then flow out. So it's basically slurry which is created and then coming out. So we should try to stop this using the injection valves so that there is no loss of rock mass which is already there in weak conditions. And then once you inserted the casing up to the desired depth, say 12, 15, 21 or 24 meter length, then these valves are opened by creating the grout pressure up to the desired level. Normally these valves are open at 3 to 5 bar pressure. So normally the grout pressure is more than that. So these valves open up. It's a kind of a non-return valve. So it opens up only from the inside, not from the outside. So those can be used. These are the drainage systems which is possible. These are extension of the tube spile which was discussed in the earlier slide. So these are the bit, the drilling drill rod. Then you have the casing which is of 50 mm dia, but this is perforated. And then you have the filter pipe. So the idea here is we drill. Just see no. These pipes are inserted into the rock mass, which is perforated. Once drilling is done, then we insert this filter pipe into this perforation pipes. So the idea is that only the water comes out without the loss of any rock mass, which is or fine particles. So only fine particles comes through these fine holes. You can see from this picture also. And then the big boulders or the small pieces of rock remains there, and only the water comes out from here. The advantage of this system is you can attach the vacuum pump here, which is of 2-inch PSP connection here threaded. So you can connect the vacuum pump here, and then which can suck the water also from the system, from the rock mass ahead of the tunnel. You can also attach this with your suction pipes and then divert this pipe into the required drainage galleries or drainage holes or line so that it does not disturb the construction activities. We use the drainage system. The purpose is to guide the water, to guide the water or channelize the water so that it does not disturb the construction activity. Like we have seen here, they have connected the drainage system so that it does not disturb the construction activity which is in the center or the face. This is the drainage system using the pipe umbrella system. Here what we are doing is the casing pipe is attached. These are the perforated steel pipe. On top of that is the GFRP tube which is attached to it, and this has the slots, the fine slots. So again, the purpose is not allow the rock mass to pass through along with the water and drain out. The idea is only to drain out the water and not the rock mass. So only the finer particles can drain out. Otherwise, the rock mass should remain there. Otherwise, it will create more cavity into the excavation which is planned. I'm taking one example from Koralam Base Tunnel. Here, if you see in the plan, you can see the blue line, which is for the drainage holes, which are much longer in length. So they are talking about 33 meter length of drainage holes, whereas the pipe proofing which is being done is only up to 21 meters. So these are the difference between the drainage system. So drainage systems are always longer than the pipe proofing system, so that you ensure that the rock mass which is to be drilled either by pipe proofing or for any purpose is dried out, and there is no less possibility of water availability, or water has been given the free passage to drain out. There are different applications for the pipe umbrella system. How it has to be used, like we know that everybody knows that it's for the weaker rock conditions, fault zone or portal situations. And if the rock is changing, especially for the cross passages or the crossings, we normally use it. Excavation or re-excavation of the collapsed drift or tunnels, then we use the pipe umbrella system. And the urban tunneling, especially whenever you start the cross passages or the area where you want to initiate the TBMs. The advantage of pipe umbrella system is installation with the convenient the jumbos which are available at sites. The pipe umbrella drilling can be done using the same operator. There is no additional requirement for a specialized drilling crew. Very simple options available, and the fast self-drilling installations which is available here. Additional requirement, the advantage is smallest possible stress relaxation, because you can drill it and then it supports the rock mass immediately because it gets in touch with the rock mass. You can do the accurate installation because of the annular gap is almost very less. Then length of the umbrella can be adapted defined depending upon the confined space or the space which is available at site. And different type of pipe couplings are available. Very common in India is the threaded connections. We will talk about that, but there are different options available. We will discuss that further. So what are the components? The starter unit, the adapter, extension rods, the casing pipe, again perforated, and then the end pipe with the end plug or the grout plug. Then what are the drilling system? There are different type of bits available depending upon the rock mass which we want to drill through. And then based on that, we select that. Now here there are different specifications available, like we discussed about 76, 89, 114, 139, 168, steel grade, etc. The wall thickness, what can be done, weight, how much is the weight, moment of inertia, section modulus, and maximum moment of elasticity. Now here the most important thing is the pipe umbrella system is always under bending stresses, correct? So it is not in any moment under the tensile strength. It can be compressive stresses sometimes, but mainly it will be under bending stresses. So we always have to consider the maximum moment of elastic. So this is more important criteria for us to select which one is the best option available. So what we have done is we have considered this maximum elastic moment M for different connections available in the world or global market. The standard pipe with nipple and nipple connections, the squeeze connections, which is a new type of connections available now, and the threaded connection. Here what we do is, if suppose we use the 114.3 mm pipe connections with 6.3, out of this 6.3 mm wall thickness, we make the thread one side male and the another one as a female end. So we take out about say 4.5 mm wall thickness and make the thread there. So we reduce the wall thickness, making the rod or the casing pipe weaker in the joint. So because of that reason, you can see in the 114, the elastic moment is only 6.8 kilonewton meter, whereas in case of squeeze connections, it's almost double. And in case of In case of like nipple connections, it's 19.4 or almost close to the standard pipe, which is as good as the original pipe connections. But in nipple connections, because you have the, like I will show you the next slide. In nipple connections, you have the higher, lower ID, because the wall thickness is much higher, because the foreign material or the external material is inserted or welded into the original pipe, and then because it has more wall thickness, the thread can be more strongly made, and this is applicable for both male as well as the female end. This is the threaded pipe which I was talking about. The same pipe has female and the male thread, so this section becomes weak in area. So the chances or the moment of elastic is lesser here in this area, especially the joint area. This is the third option which has been developed based on the request from the contractor and the designer. The advantage of this is it does not have any thread. This is only squeezed at before the supply to the site, and the other end is squeezed at the jumbo while insertion of the pipes. This is what we have seen in the standard thread connections. Even though wall thickness is much higher, like 8 mm or 10 mm, but you can see it's a damage. So once it is lowered or sent to the site for installation, then it will be difficult for any operator to load it. Whereas in case of these squeeze connections, since there is no thread, there is no problem, even though if there is a damage on the edges, etc., because the jumbos can do the squeezing at the site, at the location itself. Now I've just compare what is the comparison between the standard thread connections, squeeze connection, and the nipple connections. The installation measurement, I'm just looking into the last recommended usage. It's only suggested to use only for the instrumentation purpose, whereas when it is designed for a pipe tumbler system, this is normally suggested to use the squeeze connections because which is feed. I will discuss that also further. And nipple connections, because of the higher cost, this is used where you have a high inflow of rock mass or difficult ground conditions. Then it is suggested because this is the strongest joint connections or the higher bending stress it can handle. Now, if you see here, the red sign, the red graph line are for the standard thread connections. This one. Now you can see it breaks sometimes. This is based on the test which has been conducted with the help from Graz University, Austria. Whereas in case of squeeze connections, this one and the nipple connection, the orange one, these are almost having the same strength. And the standard pipe also has the same strength. So when you see the strength or the load it can carry is, if suppose your thread connections can carry up to 100 kilonewton, this is almost 180 or 160 or something like that, above 160 in any case. So it's almost 50 to 60% higher than what is suggested for the thread connections. So we were talking about 114.3, 6.3 mm wall thickness. Now coming into the second slide on this extremely elastic design. Again, I'm talking about the same 114.3, 6.3. Moment of inertia, if suppose you see regular pipe connections 19.4, what we have discussed 12.2, and this is standard threaded coupling is 8.1. So elastic moment is 42. Either here it is 63. This is if suppose 100. So this is the difference between the two. And because of this, if suppose the design says that 42 is acceptable or 8.1 is acceptable, then the squeeze connection gives the options to reduce this wall thickness further. We can go for 5.3 or 5.5. Just for your example, for knowledge, Japan is working on reducing the wall thickness further because there is no point increasing the steel weight on the roof, which is already in weak. So they are talking about 4.5 wall thickness, which cannot be possible with threaded connections, which can be possible only with squeeze connections or the nipple connections. So there we have done the first trial with the contractor in Japan with 4.5, and it was successful. So they will be switching over from 6.3 to 4.5 now. So just for your information, this will also reduce the cost for the customer, because the idea is, if the design permits that, okay, this should be the maximum elastic moment 8.1, so the squeeze connection can have further reduction by going for the lesser wall thickness to go with 8.1. If you are interested, I can just play one video which will give you the idea how the pipe roofing with squeeze connections take place. This is with 168.7 wall thickness, sorry, diameter. We are inserting the injection bolts. This is starter unit. The starter unit. Now this unit is the squeezing unit mounted on the jumbo. Now they are making the joint for the starter unit now. So you can see the water is coming between this drilling rod and the casing. You can also see the space between the roof and the pipe roofing which is being done. It's very close to the roof. Now they are adding the other pipe. This is squeezing casing pipe. drilling is complete, so they are recovering the pipes. This is the unit which we were talking about, the squeezing unit, which can be mounted on any jumbo. So he's explaining how it works. This is the tool which is used for opening the extension rods. Just giving the comparison how you can save the time. We are talking about the 114.3 mm wall thickness. Number of pipes, suppose we are talking about 15. Standard length is 3 meters. Length is say 18 meters. The total number of connections based on 15 pipe will be about 75. Then single connecting time for threaded connections is say 3.5 minute. So single delay, suppose there is a delay because of the thread connections is not correct, say around 10 minutes. Number of difficult connections could be about 5%. All those aspects, if considered, the total time used for one cycle of umbrella of 18 meter length and 15 pieces is say 300 minutes. Whereas in case of squeeze connections, it could be hardly 112.5. So we save about 187, which is about say 3 hours in pipe umbrella system. So this is the straightaway saving, which can be converted into the saving for excavation, because the contractors are paid for the excavation, not for the pipe umbrella. But if suppose you do the pipe umbrella system faster, you are paid if suppose it is item based pricing, and save this time for the additional work which is built. And this also ultimately improve the completion cycle. One more advantage of automation or the squeeze connection is you can see if suppose you use the threaded connection, naturally you have to make some space from the roof for the helper to work on, so that he can make the connections. And sometimes the joints are so tight, it's difficult for two people to handle it. Like here you can see he's taking support from one pipe to make the joint. So this is how the conditions happens. Number two, you need to have the higher lookout angle, 5 to 8 degree. Whereas in this case of squeeze connections and automation unit, it can be hardly up to 6 degree. This is very close. And then you can see the distance, it is very close to the roof. So your overbreak or the overbreak is much lower compared to these area, because you have the sawtooth sections with the pipe proofing system. Here, this is again saying the same thing, that how much you save. Like if suppose with this you have about 100%, here you save what maximum you say you have only 70% of additional excavation area because of this C saw or other sawtooth activity which happens, because ultimately it has to be filled with the concrete to make it plain. So you save about 30% straight away by using the automation and the squeeze connections. Now, how much you save threading unit? We also have a threading unit which can avoid the people to use the pipe wrenches, etc. So there you can save to 50%. Squeezing unit again save 50%, but with automation unit you can save 100% time for pipe umbrella system. As far as Indian conditions are concerned, there are two projects which comes to my knowledge. One is the Rohtang Pass, and second is Delhi Metro. They have used the automation unit for the pipe proofing system. Why it is being used? Say because safety, compatibility with the existing drill jumbo, shorter manipulations and faster. Simple remote control, you can feed it if you go with the automation unit. Lesser manpower required with automation, and optimized utilization of the working space. And then the most important is the less excavation volume, and then ultimately use the lesser concrete. This is the squeezing unit, how it can be mounted with the automation unit. The accessories, what we have the my pump for this, the recorder for my, or how much the grout it is being formed in. So everything is recorded. Now coming to the last point, which is the post support, which is being done after the excavation is done based on the rock mass requirement. So as per the design requirement or the site requirement or the site geologist recommendations, we select which rock bolt has to be used or selected. Now, DSI is in one of the working group or ETA Tech, the group which has submitted the report to International Tunneling Association regarding the recommendation for rock bolt, where it has to be used and how it has to be used. So there are different criteria. I have selected two tables. First table is based on the decision criteria, which rock bolt has to be used under what conditions. So this is what it explained, like if boreal condition is stable, collapsing or water bearing, then which bolt has to be used. Like if the rock mass is stable or boreal condition is stable, you can use any bolt. There is no suggestion. There is no difference between any bolt. But if it is collapsing, then you can use either the self-drilling hollow bar or SDA, or you can use the self-drilling friction bolt. There are only two options available. And when it has the water bearing zones, then expandable friction bolt, which is like Omega or Solex type bolt, resin grouted bolt, or water expandable friction bolt. So based on these conditions, we can select which bolt has to be selected at the for the rock mass. On bolt, based on the bolt property also, we select which bolt has to be used. Like expansion shell, where it has to be used, activation type, tendon shape, tendon material, securing agent. Like expansion shell, mechanical anchored, the pre-drilled hole you require, then pre-tensioned. Then what are the material, steel or GFRP? So based on that, you can select which one is to be used. Here we are talking about the rock bolt property. Now coming to the specific rock bolt, I think everybody knows how the SDA look like. So I will not go into the video here. If required, you can just tell me if I have to play the video here. So it is basically the bit, which is in red in color, the anchor, the coupling, then the nut and the plate. This is used in a combination. You can increase the length based on the by adding the coupling and the additional anchor system. There are various options available for SDA, right from R32. R means the rope thread. 32 is the diameter of the, or rather the OD of the tube or the rod, and it goes up to 101 mm diameter. So, but normally for tunneling, it's only up to 76 mm, which is very commonly used. But in each category, like R32, there are various options available. It could be lighter version, stronger version, or the normal version. So based on that, we select which is suitable for us based on the yield requirement or the yield strength requirement. It is used for rock bolting, face anchoring, reinforcement, foot piling, and tunnel portal. We use this different type of bits to drill through the different rock mass. Like suppose you have the hard rock, then normally we use the highest, the hardest rock bit, which is the button bit with carbide insert. The red ones are all with carbide, whereas the black ones are with the hardened version, which is mainly for the soft rock or soft ground conditions. But wherever you have the hard rock, because the desire is to reach to the desired depth of rock anchoring. So we ensure with the suitable bit which one is suitable for reaching to the desired depth. There are different options available for grouting. One is the post grouting, this one, drilling and subsequent grouting, and the simultaneously drilling and grouting, where we do the grouting while drilling itself. Especially this is used especially for portal stabilization or the slope protection, whereas this is used for normal rock drilling or radial bolting, etc., or inside the tunnel, etc. So we drill and then we use the post-injection adapter and then grout the entire length. Whereas in this case, because the rock mass is already in weak or fracture, it's difficult to grout them at a later date because the grout may flow out from any cracks or the cavity which is available and does not reach to the desired depth. So it is always advisable to grout it while drilling itself. So this is commonly used for slope and portal protection. This is the adapter which is attached to the drill machine for simultaneous drilling and grouting. And this can be attached to any drill machines. The self-drilling anchors can be of different options like normal steel, the black version, the hot dip galvanized version for higher corrosion conditions or situations, or the duplex or double protection coated, where you can go for the higher corrosion conditions. So based on that, we finalize that, okay, what could be the estimated life of particular rock bolt. DSI also have a marking on each anchor, because this was one of the question which was raised by one of the client at one of the presentations. So we suggested that each anchor has a marking on each bundle or batch, and this is correlated with the inspection certificate or the test certificate which we share with the customer. And we can correlate that this is manufactured under which test certificate. Same cases with applicable with the all accessories, including the coupling. So we can correlate easily that how and what are the criteria, and then whether it has been tested properly or not. The tube spile which we discussed earlier is the same, but here I can just share the installation process. So this is drifter, which is the jumbo. Then you have the bit, the rod. You start inserting this once you reach to the desired depth of say 3.5 meter, 4 meter, or 4.5 meter length. You simply withdraw, just pull out the drill rod. This is of hexagonal shape, so there is no requirement of rotation. Just pull it out, and then the bit remains there along with the casing which is inserted into the rock mass. So this ensures that the entire length of 4.5 meter is inserted into the rock mass and is now supporting the roof. This is the pipe roofing, tube spile with vacuum lenses. Vacuum lenses is to use for drainage system. As we discuss about this, this is the pipe which is having the perforations, and then after, yes, okay. Installation process is like we drill it up to the desired depth, take out this drill pipe, and then we insert the filter pipe here. And then since it has the 2-inch BSP connections here, it can be the water which is coming out from here can be diverted into the drainage channels. The advantage of this, the green filter pipe is you can clean these holes by using the compressed air. Otherwise, it will be difficult, because once these are packed up with the fine cuttings, you can push the compressed air slightly higher in pressure up to say 10 bar or 5 bar. Then these can remove, and then you can still find that okay, water is coming out. So if you have the situations like the water is not coming out or everything is fine, no, just try to clean these channels and see if water is coming out or not. If not, then naturally the water has diverted and gone to some other place. As I suggested that, okay, this can be diverted like this. So what they've done is they've used the vacuum lenses only at the right and left side, 2 here and 1 here. So wherever you have the possibility of water, then it can be used, and then the water can be diverted, keeping the face almost dry for the construction activity. This is my pump we promote. This is manufactured by My International. Up to 40 bar pressure and can give up to 2000 liters per hour flow rate. Now coming to water expandable friction bolt, also commonly known as Swellex bolt. We call it Omega bolt because of its shape like Omega. And how it works here, I can just play one small slide video. You can see to it. So high pressure water is injected through the tube, and then this is pushed to the original shape. But because of the lesser diameter of the borehole which has been drilled through which it has been inserted, this cannot expand to the original shape. The water is injected through these holes from the bolts. So once you inject the hole water, they inflate like this and try to gain the original shape, which they are unable because of the lesser diameter of the hole. And with this, they create the friction between the rock mass and the steel pipe or the casing, the bolt. So making a support system. So the advantage of this is it gives the immediate support. So whenever you have the requirement that, OK, the formation is good enough, it can hold on. So you can insert this immediately and it supports the rock mass immediately. It can be installed within 1.5 minutes maximum. So after drilling. Low sensitive against vibrations. So if there is any vibrations, etc., there is no problem for this. Even if you have the water in this, also there is no problem with these anchor system. The power set drilling system. This is extension of self drilling. Rather, it's a combination of self drilling and the friction bolt. How it does basically, you can just use this bit on the drifter, insert it up to the desired depth, say 3 meter, 5 meters. Then insert this and then take out the drill rod and the adapter, the bit and the friction pipe or the friction anchor will remain inside the hole. So purpose or rather drilling method is the hole is drilled slightly lesser than the OD of this friction bolt. So once you insert, this is squeezed and inserted into the rock mass. As soon as you reach to the desired depth and or the bolt is inserted, this is in action. So there is nothing required like the pump, the grout pump or the water pump, etc. You just drill and it's active. So this is very much very much suitable for the ground conditions where the rock is slipping in nature. So you just drill and then it does the job. It does not allow the rock to slip through. So in those conditions, it can be used, and it can be again used or drilled through using any kind of drill machines, including the surface drill machines. Same how it is being drilled. This is being drilled inside the tunnel, but more common, especially in the Indian conditions, especially Himalayan geological conditions. I've seen in border roads. This can be more popular because of the slipping rock mass. The other CT bolts, the combination bolt we call it, and this is used where you want to have a much longer life. This has like a combi coat, like galvanized. After that, it is double corrosion protection, and then grout also is double. So the grout comes. If I see, yeah, I can see. The next slide, if you see, once the anchor is inserted, the grout is pushed through, which is red in color, comes from the inside and then goes out. So you have the double layer of grout, cement grout, double protection for the anchor system. And because of this reason, this rock bolt is suitable or said to be life of about say 100 years. So where you have a longer life requirement, CT bolt is preferred. This is also recommended for the area where you have a longer reach, like the powerhouse area where you want to drill or rather insert the holes, which is difficult to reinstall later on because of any reasons. So there the CT bolt can be preferred. These are the normal rebars or the SN anchors which is being used. Normally these are made locally at site, so not going into much detail, but we have the Alba grip, which is again patented by us for higher strength. We also promote the SN anchor with the expansion shell, so that the requirement for the resin capsules, or in case it is not available, the expansion shell can hold the SN anchor, and we can do the cement grouting or use the cement anchors, cement capsules or resin capsule as such. But the expansion shell also give you the advantage of initial anchorage. So without doing the the grouting, you can still go ahead with the initial anchorage provided by the expansion shell. The resin system, resin capsules, we also provide that. Then we also have the lattice girder, which our patented name is Pentex lattice girder. If I remember correctly, it has been used initially for DMRC. And now again, these are available locally at site by most of the contractors. The lining stress controller, this is again a major discussion, especially in tunneling under the squeezing ground conditions. So it's like a compressive spring, and it's especially designed and tested so that it can take the load of the squeezing stress zones and avoid the breaking of the lining which has been created for tunneling. These are the standards, either two or single lining of LSC, depending upon the load it has to carry or work through. So this is installed. And then once this is complete, and then it can be selected based on the stretch also. Like it is not required that the entire length of the tunnel has to be used with LSC. It's only the stretch where you have the squeezing ground conditions. There it has to be used. The advantage, as I said, the immediate, the ensuring that the permanent, sorry, the lining is not damaged using the lining stress control by using the lining stress lining LSCs, and this can be installed while doing the lining. Casing system we have already discussed different options. We also have the injection systems, but here I will say that we suggest that we go with these table, and based on that we select which one is suitable for the different situations. Like suppose you have the ceiling cracks, then what are the different options available? Either it can be silica based or PU based. So based on that we select that which one is to be used. Like for higher strength we use the silica based. For lower strength we use the PU based. Then we also have the high pressure pumps for resin and gels. We also have the waterproofing system, which is again the sheet option. It's not like a chemical or the injection, but we use the sheet which is placed into the entire locations where you want to do the pipe proofing. But these are suitable. This has a limitation that it can be used only in the plane or the surface area which is clear. There is no hurdles like the edges or the connections, etc. That's all from my end. I think I have taken some little more time than allotted to me.
Thank you, sir.
Thank you, sir, for making an excellent detailed presentation on support system for tunnels. Now we request to the participants, if they have any questions, they may ask directly.
You can also send the questions to her, and then she can direct to me for any questions. And my slide, I think the presentation will be shared, which also has the phone number and the email. So you can directly write to me for any questions or any clarifications, etc. later.
Okay, sir.
Yes, if the participants have any questions on a later stage, they can write to us or to the speaker directly. We will arrange the respective answers and get back to you over the email. If anyone wants to ask any question directly, they may ask right now as well. I guess we don't have any question.
Yep. Thank you everyone, and thank you. I especially thanks the CBIP and NICOL for inviting me for making a presentation and interacting with all the eminent people who are working at the project sites. Thank you very much.
Thank you, sir, for sparing your valuable time for conducting this virtual session. Thank you once again and have a good day.
Thank you very much. Bye-bye.
Bye. Here we conclude this 2 day session as the last speaker has some technical glitch with his system. His system got crashed. We will be going to arrange the presentation. If we could, we will be able to share along with the participation certificate to individual participants. Thank you to all the participants for attending this 2 days virtual workshop on construction of dams in weak rocks. Thank you all. Stay safe, stay healthy. Goodbye. As we have already mentioned, if any of the participants have any questions, they may write directly to us related to any topic, any session. We will arrange the respective answers from the respective speakers and will get back to you over your email IDs. Thank you once again to all. Thank you. Stay safe, stay healthy. Bye.
Thank you. Bye-bye. Namaskar.
Thank you.
Namaskar. Here we conclude this session as well. Thank you.
Thank you so